Alright, hello everyone. This is the tutorial on how to do the Patel and Coet flow. The first thing we want to do is open up Workbench. Queue it up a little. Sometimes these programs take a little bit to open just because of how much simulation there's going on, how much it takes for them to run these simulations. Alright, once we have this tab open right here, we're gonna want to go and find Fluent, and drag it in. First thing we're gonna do is go to Geometry, right click, and then select a new design model. Make sure that you do not click on any of these two, as you won't be able you won't get the same options. This was a problem that I had, um, and it took me a couple hours to be able to figure out what was wrong with the actual problem. The next thing we're gonna do is just normal ourselves with the XY axis. We're gonna create a new sketch right here. On sketch, we're gonna go to sketching. I'm gonna create a rectangle. It doesn't really matter at first what sizes we do. What we do now, which does matter, is we're gonna go to on sketching. We're gonna click on dimensions, and then we're gonna click here and here, and we're gonna change the V1. My bad. Sorry, we have to change the units here to millimeters. We're gonna change the V1 to be 5 millimeters, and the H2 to be 250. The ratio is it's 1 to 50. So for everyone we are right here, you have to have 50 here. Once we have these, we have to zoom in a little bit because of how small it became. Alright, now that we have this here, we're gonna go into concept, surface from sketches, and we're gonna click on this sketch right here. You see that all the sides are yellow. We're gonna click apply, and then we'll click on generate. We're gonna get a flat surface right here, which is what we're gonna be using for our simulation. This is gonna be simulating what a tube is. We can minimize this. Next, we're gonna go into mesh. Again, this sometimes take a little bit to open, so it's fine if it takes a little bit. Some computers might be faster than others. I'll make sure that you get the same shape. Again, we're gonna normal into XY plane. The first thing we're gonna do on the uh, on this side of the app is gonna be right click, insert method. Over here on method, we're gonna click on this rectangle, apply, and then we're gonna generate it. You should be getting something like this, like a little bunch of sections. Make sure that it's not. If you see this blue thing, make sure you click on mesh so that you can actually visualize what is happening. The next thing we're gonna do is right click, insert, then we're gonna insert a sizing. This time we're gonna select these two corners. Make sure you control selected. Make sure both of them are selected. You're gonna click on apply. This is the two edges. We're gonna click on type, number of divisions, and make sure this is set to 100. Make sure that whenever you have this capture curvature, make sure it's set to no. And for this behavior, we're gonna set it up to hard behavior. Once we have this, we're gonna click on generate, and it should look something like this, kind of like a broken window pattern. If you zoom into these corners, it should look something like along these lines. This is what it should look like. The next thing we're gonna do is it's something similar. Insert sizing. We're gonna now select the upper and bottom wall. Apply. Same thing. Make sure this is set to no. And hard behavior. Over here. if I'm not wrong, I should be able to. Right here, number of divisions, and then this one we're gonna set to 500. Generate. Now it should look something like this. A little bit more squared up. Same on the end of the sides. It should. Sorry. There. On the end sides, it should look something like that. A little bit of that similar turtle shell pattern. The next thing we're gonna do is another insert, face meshing. Then we're gonna click on this face and apply, and then generate. Now, if you did everything correctly, it should look like a solid black bar. However, if you zoom in, it should all be divided into these evenly selected rectangles. Even on the edges, it should also look similar. So like that. That's how you know you did it correctly. Now, just for ease of information and to make sure that we don't mess anything up, we're gonna start naming these walls. You click and then press N, and then we're gonna name this inlets. This one we're gonna name outlets. This one we're gonna name upper wall. This one we're gonna name lower wall. Once we have this done, make sure that these are named. Inlets, outlets, upper wall, lower wall. Perfect. We're gonna go back into Workbench, and we're gonna go into setup right here. We're gonna write. Oh, before we do anything here, make sure that you update this so that this checks on both of these. There you go. We're gonna click on this edit. Make sure that this is set to double precision, and then start. You should be getting. Give it 1 second. You should be getting something like this. If you zoom into this, you would see that these are actual arrows, and then you still have here the same grids. Once you're into this step, the first thing you're gonna do is go to models. Over here, you're gonna go to viscous. Double click it. Double click this viscous. Make sure this is set to laminar. Click OK. Next thing you're gonna want to do is go to materials, fluids, air. Make sure that this air is the density is set to 1, and the viscosity you also want to delete all this precision. Change and create, and then close. Now what you want to do is go to here, boundary conditions. You want to go to inlets, and then inlets right here, edit. And then right here, what you want to do is where the velocity, you want to set this. I'm sorry. This is usually normal magnitude and directions. Let's open this again. Magnitude, normal boundary. Just leave that. Don't touch that. Where it says velocity magnitude, set this to 8 meters per second. I found that this is the number that works the best for me. Gave me the best results. Apply. Close. Now we go to reference values. Right here. And then right here where it says compute from, make sure that it is set to inlet. Then what we want to do here is go find initialize, right click and initialize. So it says right here hybrid initialization is done. And then right here it says run calculation. Double click this, and set this number of iterations. I'm going to set it to 200 and then click on calculate. If you took modeling methods, you should know what this chart is. Once calculation is done, um, once this calculation is done, you want to go to results, vectors, select new, and then just click save and display. Don't change anything there, and you should be able to see right here. This is the results that we're looking for. Basically, what this means is there's a pressure coming in, or there's a fluid coming in from this inlet coming out of the outlet, and it's creating a boundary layer on the upper and lower wall. This is basically what this little simulation shows. We're gonna want to close this right here. We're gonna go back into Workbench. Make sure to update these results. We open. Now we go here. Open these results. You should be able. You should get something empty like this. That's fine. What you want to do is now go to contour map, which is right here. Just click OK. Number of contours, I'm going to set this to 100. Location, I'm going to set location to be symmetry 1. Now we're going to go to variable and make this is equal to velocity u. Alright. Apply. And right here you can see that this is a similar result, but it just looks way better than what we had. You can see it varies on velocities and the different velocities you're gonna get along the tube. Now just to make this look a little prettier, we can go here into default legend. Just click edit and set it to horizontal. And on appearance, we don't really need this all position. We can just set this to 1 and then apply. And as you can see, we're gonna get much better results. This way we can have a little bit more of this the simulation right here with the velocity values up here. Make sure this is also set to fixed. We don't really need all these numbers. Like that. Perfect. Now, we can go to where is it? Title. You can change the name of this if you want. You can change it to whatever. I'm just gonna leave it to this. Right now, if you wanted this to just be velocity u, you would have to create it again basically. So let's delete this. Just do it right from the get-go. Velocity. Okay. Oh. Let's change just the same thing. 100. This location. Symmetry 1. Variable velocity u. Label under geometry. Apply. There you go. Alright. Now we have to analyze what the midpoint and the endpoint are going to create. So the next thing we're going to want to do is go to location, create a line. We're going to call this one midpoint. Um, right here, we're going to want to make sure that this point is at 0.125 and then 0.125. Again, this is the midpoint for my values. Uh, you would want to basically grab the entire length of your tube and divide it by 2, and then that will be your midpoint. And then for this is going to be the top side. The top one is going to be 0, and my bottom one is going to be 0.005. These values are in meters. Again, this is the lowest size, and this is the highest size right here. For samples, I'm going to create 100 samples, and then apply. And if I'm not wrong, right here, you should see that it has created one of my points. I'm gonna do the same thing: location, line, and this one I'm gonna call endpoint. Okay, this one is gonna go in 0.2459, 2495. Sorry, and 0.2495. The reason why we don't do it all the way to the end is because it kind of like lapses over, and this way is gonna look a little nicer. It doesn't really change much of the actual result, so it should be fine. But for this value right here, we should do the same: 0.005, and then 100 samples. Then we can do apply. We zoom out. We can see that right there. We got another line. Now we wanna get results on this chart. So what we're gonna do is go here, insert. We go into where's this chart right here. We're gonna change this title to velocity profiles. Click OK. And then right here it says data series. Where is it? Right here, where it says data source. We're gonna choose midpoint. We're gonna call this midpoint. This is the title that's gonna show up here. And then this x-axis, we're gonna have velocity u. Y-axis, which you're gonna have y. We're gonna click here to create another one. This one's gonna be the endpoint, and this is gonna be endpoint. And all this information is gonna basically translate into all this is gonna be the same. We're just gonna click apply, and you should be able to get these two results. The red one is gonna represent the midpoint right here, and then the blue one is gonna be represented the midpoint. I mean the endpoint. You can see that the velocity is also variate, which basically complements what we see on this right here, which velocity of the fluid is a lot higher at the end, in the middle, than it is over here. All right, so this is this type of flow. The next one we're gonna do is the co-ed flow. So all we really have to do is go back to Fluent. Oh, by the way, if you want to export your values so you can get the actual numbers and everything here, you can go here, files, export, and right here. What is it? Velocity U. Right here, I'm just gonna save this into my desktop. Let's call it pflow. Save. let's try that one more time. Oh, sorry, is this file export? This it has to be on Fluent. I'm sorry. Um, exports. Mm, where is it? All right, we can. Oh, here's. These are your actual values for velocity use and everything. If you want to check it out, you can use this information into your actual report for what you will be finding and to find your actual highest value on the entire simulation. We're going to delete this just because we don't really need it right now. Now, if we want to do the co-ed flow, we will go back onto Fluent right here, and then we will change the material right here, air, edit. We're going to set this to 0.01, and then we'll create, close. We'll go to boundary conditions, right here, and the same thing. We'll go inlets, right here. Where is it? Is it this one? Over here. Inlets. Oh, right here. Double click into the boundary conditions. Go to inlets, and where it says type, go to pressure inlets right here. Then apply, close, and then over here where it says upper wall, we want to make this into a wall motion, and then set this to moving wall with a speed of 0.1 meters per second. Apply, close. Once we get this done, we go here to reference values, compute from, and one of this changes to inlets. Once we get this done, we go to initialization and initialize. Make sure that this does the calculations. Let's do this one more time. And then calculates. Leave it for a little bit. This is our second scale of residuals, and this looks about right. This is a co-ed flow, which basically means that it's the top wall that is moving rather than the fluid actually coming in from the right. Right here. You should be able to get something along the lines of this. Basically, it just kind of looks like Rambo. Now, once we get this done, we want to go into the change this up right here to Fluent. I'm supposed to change this to default. So where is it? We're gonna go from Fluent to PST. Where it says new upstream data exists. Once you change it, it means that it's asking you the data has changed. Do you want to refresh the simulation? You're going to click yes, and then you're going to get the same simulation here. What you're gonna want to do, the good thing is I already set up the all the legend and everything. So right here we need to change this again because we actually need to be able to see these values. So default legend, edit, and we're right here where it says appearance. We can go back into set this into 3, apply, and right here you can see the values again in decimal points. And right here, easy peasy. Really, you already got the results. Basically, again, like I said, is like the top is the upper wall that's moving this time. So the highest velocity is going to be on the upper wall rather than on the bottom. Now, if we want to do a combination of both of these fluids, which is the final part of this project, we're going to go back here into this app and then change the material right here, fluid air edits. We're going to set this viscosity to 1e to the -5, which was what it was originally before we changed it. We want to go to boundary conditions, and on inlets, we're gonna edit this. Oh, my bad. Right here, inlets. We're gonna set the type. Where is it? Oh, my bad. I'm sorry. It's right here. Double click on boundary conditions, inlets. Which says type. We're gonna change it to velocity inlets right here, and then apply. Leave it to 8 meters per second. Close, and then we go to upper wall. Same upper wall right here. Type. We're gonna leave it as is. We're gonna edit this. Make sure that this speed is set to 8 meters per second, which resembles the same speed that the flow is gonna be coming from the inlets. We're gonna click apply. Click close. We're gonna go back to here to reference values. We're gonna make sure that this compute is coming from the inlets. And we're gonna run the calculations again. Calculates. Oop. Initialize and calculate. Alright. Now this looks a little weird. It's just like a red bar. Oh, red bar. However, if we go back into PST and we update this, you should be able to see the combined results right here. These is basically the same results well, a combination of the same results from the two distinct flows, which basically means that there's a flow coming in from the inlet and this upper wall is also moving. And as you can see, it is a combination of both the boundary layer and the highest velocities being around the middle. In this case, I would say it's about the third, fourth upper side of the tube. And yeah, this is basically the tutorial. Thank you so much for watching.